Hello and welcome to a quick lesson on graphing a rational with a removable discontinuity. One of the first things you want to do when you look at your rational is identify the end behavior just for comfort level here. We notice that it's x squared over x squared, so we'll approach a horizontal asymptote at the ratio of the leading coefficients, -4/1. We'll cover that in a moment. But first we'll factor. And we notice on the numerator we can factor out a -4x, leaving x minus 2. And on the bottom we have a difference of squares, x plus 2, x minus 2. And it's nice to notice right away that we have a common factor, top and bottom. We can just cancel those out. And what we'll do is identify the x-coordinate of the removable discontinuity at 2, and then we'll find the y by plugging in the value to the rest of the function. But first we'll find our zeros. In this case, there's a 0 at 0 and a vertical asymptote at x equals -2. The removable discontinuity, when we plug in 2, we get -4 times 2, -8 over 2 plus 2, and that's y of -2. The y-intercept value of y when x is 0, we've already found it actually, because we had a 0 at 0 as well. And as mentioned earlier, the horizontal asymptote, the ratio of the leading coefficients, that'll occur at y equals -4, which means if we take the limit or we approach a really large negative or really large positive value for x, y will tend towards -4. Not quite reach, but get very close to. And now we're ready to make our sign chart. The key values for x are 0 and -2. And when we plug in large negative values, we always have a negative on the numerator. So large negative, negative times negative over negative, that's 3 negatives, meaning we'll approach a negative on the far left. Plug in -1, again we always start with the negative here. -1 times a negative over -1 plus 2, that'll be a positive for a net positive. And then large positive values will become negative. All right, vertical asymptote occurs at x equals -2. And our horizontal asymptote is at y equals -4. Now we're ready to plot some points on this graph. We have, as mentioned, our removable discontinuity at -2, so it sits above our horizontal asymptote, and a 0 at the origin, as well as the y-intercept, obviously. And now let's interpret our signs. Negative to the left of -2 means a branch that approaches both of those asymptotes. And on the right, we have to approach positive infinity along this asymptote, and then we have to go negative and approach the horizontal asymptote, so we'll jump over the hole and go to there. There's a quick lesson on graphing a removable discontinuity in a rational.